Hello everyone, welcome back to the part 2 of section 1.5, dividing complex numbers. So usually I like to say this in like words. To simplify the quotient, let's say you have something that look like this, a plus bi all over c plus di. It doesn't matter what a, b, c, and d are, they're just constant numbers. If you have that though, what you want to do in order for you to kind of get rid of the bottom imaginary, the c plus di, you're going to have to multiply the numerator and denominator by the complex conjugate of the denominator. So in other words, let's say you have this as your problem, right? Whatever your denominator is, in this case it's just c plus the I. What you want to do is that you're going to multiply by the conjugate to the top and bottom. The conjugate is the same as the bottom, but the only thing that changes is the sign, which is the negative. So it'd be c minus di times the bottom and the top, which, you should get something like this as your new problem. So for our first example, they want us to express the following in the form, again, I'll just call it in standard form. And remember, standard form is the same thing as the a plus bi. Okay? So they still want us to do it in this form. So let's say you have 3 plus 5i all over 1 minus 2i. Well, how do we solve for this? Well, luckily, we know the rule of thumb here, dividing. We just multiply the conjugate base of whatever the denominator is to the top and bottom. Here, it would be, usually, let's just rewrite it, so it would be, 3 plus 5i all over 1 minus 2i. So it would be the conjugate base, right? So what would it be? I'll give you guys a second. You guys can pause the video. But it would be 1 plus 2i to the top and bottom. So when you do that, for your top, you get, because the top you're going to have to FOIL, you get 3 plus 5i plus 6i plus 10i squared all over 1 minus 4i squared. So remember, I squared equals 1. So, equals to negative 1. So when you do the whole replacing, you get 3 plus 11i, because they just combine like terms, minus 10, because the I squared just replaces it to a negative 1, all over 1 plus 4. So then you get, negative 7 plus 11i all over 5. But since they want it in standard form, the way you write this would be equals negative 7 over 5 plus 11 over 5i. Hence, a plus bi, that plus is just arbitrary, so it'd just be a and b and I. And that would be your final answer for this particular problem. But yeah, conjugate base is always important. Well, what if we have another problem? What if you have something that looks like this, 7 plus 3i all over 4i? So you might be asking, well, what the heck is a? Like, it only gives you bi at the bottom, but not a. There's two ways you could write this. You could rewrite this as 7 plus 3i all over 0 plus 4i. Because technically, this is the bottom denominator is the same as this. I just added that 0 plus, so it doesn't really matter what it is. So now you're able to multiply by the conjugate, which is what? 0 minus 4i to the top or to the bottom and top. So when you do that, you end up getting at the top 12 minus 28i all over 16. And the reason why I got 16 is because when you do 4, you get, actually, let me write it so then that way you guys can see it. You get negative 16i squared, right? But that I squared just turns into a negative 1, but there's already a negative there as well, so it gives you 12 minus 28i all over positive 16. Of course, they want us to write it in the standard form, so we have 12 equals 12 over 16 minus 28 over 16i. But again, you're able to simplify both of them because they're simplified. You're able to divide this by 4, and then this you're able to divide by 4 as well. So your simplified answer should be 3 over 4 minus 7 over 4i. And that is the answer for part B. Yes. So these are just two different problems that you might encounter in your homework or quizzes or tests. But that is how you would solve for these. So now the next section was the square root, the square roots of negative numbers. Well, what if, usually, you will see this eventually in your algebra courses. What if, or usually just the principal rule, what I would recommend. So let's say you have a negative r. R is just another real number. How would you figure that out? Well, again, what we did earlier, you're able to call negative 1 r I squared, right? So you could have I squared times r, right? Which kind of leads to I radical r. So just know this rule of thumb. You're able to kind of convert that backwards. So when it comes to an example, how would you solve for negative 1? So let's say I'm asking you, solve for radical negative 1. So what you would do is write it down again. But then we know that it's 1 times I squared. Since I squared is negative 1, which then you're able to simplify. You're able to take the square root of I squared since this is I. So your final answer should be I times radical 1. But we know that radical 1 is just 1. So your final answer is I. Well, for example 2, let's say you have radical of negative 16. So how would you solve for that? So again, negative 16. We know that negative 16 is just 16 times I squared. And we know they're both perfect squares, right? It is just 4ni. So your final answer would be 4i. And then for example 3, let's say we have negative 3. So how would you solve for that? Oh, that's not that doesn't look like a 3. It's a negative 3. So again, rewrite it. And we know that negative 3 is positive 3. Positive 3 times I squared, which is just I times radical 3. Yeah, and these are your answers for these problems. So this is how you kind of solve if you have a negative inside a radical. And this is how we deal with them. Well, let's say now they want you to evaluate, right? They want you to evaluate the following. Let's call it radical 12 minus radical 3 times 3 plus radical 4. Well, right now, there's a lot of numbers. Actually, let me write that so you don't get confused. You might be asking, well, what the heck is this? So many things going on. But no worries, they're just radicals. You're able to kind of reduce them. So what you always want to do here is try to FOIL. So when you FOIL, you end up getting whatchamacallit. No, not FOIL, sorry. You're gonna have to rewrite them. So you know how some of them have a negative inside the radical? So you want to convert negatives into an I. So you have radical 12 minus 3i squared, right? Because that negative, right? And then 3 plus 4i squared. Remember, because that negative is still here. So I'm just replacing the negatives inside the radical for I squares. Now, you're able to kind of reduce it as well. You're able to get rid of one of the i's since they're perfect squares. So you have I to the radical of 3, and then 3 plus 2i. Since they're both perfect squares of 4 and I. So yeah, just so then that way you know, perfect squares. And then after this, what I would suggest is kind of put every I together and every real number together. So what I mean by that is that so you're gonna have, what is it? So after you FOIL, you should have 6 radical 3 plus 2 radical 3 plus I 2 times 2 radical 3 minus 3 radical 3. So after that, oh, that's multiplication. After that, so here let me FOIL. This is what you do here. So this is just FOILing. So after you want to have it in standard form, your final answer should be 8 radical 3. Oh my god, my 3's are so bad. I'm so sorry. 8 radical 3 plus I radical 3 as your final answer. So now this would conclude this section actually for 1.5. For next, or not next week, but for the next video, we're going to be talking about 1.6. So we're moving on pretty quickly now. 1.6 relates to solving other types of equations. So this one, you're gonna have different scenarios, meaning you're gonna have some with just an x cubed, x to the fifth. There's different types of areas. So that's what we're doing for the next video. So if you enjoyed this video, if you find it informative, please give it a like, subscribe if you haven't, share it amongst your peers, your friends, your family members, anyone that might find this useful. And I really appreciate the love and support from all of you guys. Other than that, I'll see you guys in the next video, and have a good one, everyone. Bye bye.